person. This is really lovely. Welcome to Vancouver Quadra's first town hall in person in just about 3 years. I would like to introduce your MP for Vancouver Quadra and the Minister for Fisheries, Oceans and the Canadian Coast Guard, Joyce Marie.
Thank you for that enthusiastic response, and I can tell you I am just like stoked to see you here and to have a first in-person event since pre-COVID. I know that we're all courageous souls, and some are masked, which is absolutely appropriate, and some not, which is appropriate too, because we're feeling our way as a community forward into how will our city and our country be moving forward in the post-COVID, but still some virus universe. So really happy that you came. We had a number of people who said they're not ready yet to be in an in-person event, and so I believe we have a camera that will be following the event today, and I think some folks are with us on Zoom. So welcome to our town hall, our hybrid town hall, and I'm really pleased that the interest in participating in this today. So I want to acknowledge that we're here on the Coast Salish unceded traditional territories, the territory of the Musqueam, Squamish, and Tsleil-Waututh peoples. And I'm very pleased that we have a representative of the Tsleil-Waututh responsible for land and resources and environmental matters, who will be sharing the Indigenous perspective on our topic today. So before I get into the other introductions, I was reflecting, and as I was thinking about coming here, I was actually outdoor knocking for the last couple of hours just to say hi to people in the community. How are you doing? What's on your mind? So I'm still in my door knocking outfit. But anyway, I was thinking about when I was first elected, and some of you may have been in town halls that I was doing back in 2008, 9, 10, a lot of focus on climate. Because no surprise, that's a key interest of mine and a key commitment. I never thought about the oceans when I was thinking about climate. So I was thinking about price on pollution, I was thinking about electricity grid, thinking about nature-based solutions, because that's part of my background and what I was working on in private sector. But oceans, it was not in my frame of reference. And I think for the country and the planet, the international community, other than some front runners, and some of those are seated here today, we didn't think climate when we thought oceans. And so, well, as the Minister of Fisheries, Oceans and the Canadian Coast Guard, one of the reasons that I was so excited and appreciative of this responsibility was that I could start exploring climate and oceans. And I will say that Canada is a bit of a leader on the international stage, believe it or not, on that element. Well, I mean, why shouldn't we believe it? We've been pretty progressive on climate since 2016. We have gone from 1% of oceans protected to 14%, and are on our way to 25% protection by 2025. And yeah, thank you. So I share that responsibility with Minister Guilbeault, who has protected areas, ocean protected areas that are through Parks Canada, and also through migratory bird sanctuary ocean areas, and I'm confident that we can meet our goals. And those protected areas, I see them as also a climate measure, because when you are deliberately carving out large areas of the ocean that can't have the kind of activities that go on in our oceans, some of which do damage to the seabed floors. There is also overfishing. The climate change is affecting the oceans. So having some that are carved out for ecological and the fish and plant and microorganism biomass to be protected, that's a climate measure. So we're hosting a marine protected area international conference through the UN here in Vancouver in February called Impact 5, where countries will come together and identify what are some common standards for protecting marine protected areas. So what does a marine protected area really mean? What are the must-dos in terms of changing our practices, and what are the specifics that an individual country in an individual area can feed into their regulations for their marine protected areas. So I'm looking forward to that. There are a number of other things that we have done as DFO that I think has a direct effect on climate issues in the oceans. Climate issues in the oceans is a very shorthand for saying that the oceans are incredibly important for our climate mitigation. Oceans cover 70% of the Earth's surface. Oceans are the majority of our greenhouse gas mitigation is through absorption into biomass in the oceans. So we need the functionality of the oceans to be able to go forward as a human community, no matter what we do on the land. There will be some emissions created. If the oceans are not absorbing them, we will have more challenges ahead. So in 2 ministers ago, that was Minister LeBlanc, I believe, or that was 3 ministers ago, we modernized the Fisheries Act, re-implemented many of the measures that had been taken out 10 years ago. And so what that's meant is rebuilding plans for fish. It's meant precautionary principle applied in how the department decides on allocations of fish. And to make the long story short, it means less biomass being removed out of the oceans. So it is the plant, animal, and microorganism biomass that is the sink for carbon. We have to protect the biomass and its diversity and abundance in the oceans. And so the Fisheries Act helps to do that, helps to prevent overfishing. There's many challenges that remain though, like international overfishing and illegal and unregulated fishing. And I'm happy to have been part of our Indo-Pacific strategy, in which a component was some $80 million to target reducing IUU, illegal and unauthorized and unregulated fishing. So there's a number of things that are going on in the federal government that I just wanted to mention in this very broad and kind of winding context painting for our town hall today. But the town hall is really for you, and our speakers have kindly agreed to create context from their sets of expertise. So I'm going to introduce very briefly our speakers. So Andrew Lang-Wong studied global resource systems at the UBC with a focus on sustainable food systems, and he had a passion for oceans, and currently works on Ocean Wise's Sea Forestation Initiative, which aims to responsibly expand the protection, restoration, and cultivation of seaweed in a way that maximizes benefits to people, the climate, and the ocean. So this is about building biomass as well as restoring ecosystems, which then restores the fish populations that depend on them. So really happy to have Andrew come and talk to us. So thank you, Andrew. Dr. Brian Hunt's an associate professor at UBC and an ocean and ecosystem oceanographer. He grew up next to and in the oceans around Durban, South Africa, and completed his PhD at the University of Tasmania, became interested in ocean science from a trip to Antarctica, and now he's at UBC where he researches the connectivity between the component parts of marine ecosystems, mostly from the perspective of food webs. So Dr. Hunt has had a broad set of experiences in places right around the planet, and he's a strong believer in collaboration and partnerships, which is what we will have to do a lot more of to really address oceans and climate in the coming years and decades. So he has extensive partnerships with the Hakai Institute, DFO, Pacific Salmon Foundation, and many other colleagues at UBC and beyond, and holds the Hakai Professorship in Oceanography. So thank you, Dr. Hunt, for taking your precious Saturday to help out here. And Charlene Aleck has been a staunch advocate for people and the environment in every aspect of her life. Charlene has a background in acting and was on a TV series where she was the principal character for 15 years. So if you were recognizing Charlene, that might be why. She works as a spokesperson for the Tsleil-Waututh Nation Sacred Trust Initiative and has been a core team member for over 8 years. And Charlene is thoroughly invested in culture and tradition, as well as making a difference in the lives of Indigenous people. She's currently serving her 4th term as an elected councillor with the Tsleil-Waututh First Nation. And I'm delighted to have Charlene here, partly because my mandate to advance Department of Fisheries, Oceans, and the Coast Guard matters with Indigenous communities as an Indigenous reconciliation measure is a very high level priority for me and part of my mandate. So I'm always interested in the partnership and knowledge-based contributions of Indigenous communities, whether it's on the West Coast, the Arctic, or the East Coast. So thank you for being here to participate, and I will wind up my introduction and we'll go, I will find out from Denez what the timing is here. Do you have the itinerary for our, is it?
Yes, we do. First, so Dr. Hunt is our
so essentially some 10 to 15 minutes per
Yeah.
speaker, and then question and answer to that speaker in between. And then at the end, we hope to have a half hour to 45 minutes for a more general discussion and for you to participate in. So turn it over to Dr. Hunt.
Okay, hi everyone. I was told 15 to 20 minutes, so I'll aim for 15. Hopefully you can all see the slides right at the back. How do they look back there? That's okay? Yeah, and you can hear well, it seems it's pretty loud. Okay, great. So you've heard my background, so that's gonna give you, that gives you some sort of flavor of probably what you're gonna hear from me today. Going to talk about Canada, well, BC's oceans and climates. And I have a picture here, a satellite image of British Columbia looking down from the north. I'm sure you recognize this. Here's Waihanus down over here. This is Vancouver Island and the Salish Sea. And I love this image because it just shows something very important about the coast of British Columbia. It's very complex. Even geomorphologically. So we see all these fjords, all of these passageways cutting into the coast. And when we're talking about MPAs, and I wasn't going to talk about MPAs at all, that's something that's very important. It's an incredibly dynamic coastline It's got a huge amount of variability and a lot of different types of habitats, and that is something that has to be taken into account when you're thinking about MPAs. And if there's time, perhaps we can talk about that later. But at a big scale, so I want to give some context here. So what is the BC Ocean? Well, we're in the Northeast Pacific, we know that. This is sea surface temperature on the left-hand side, and this is chlorophyll A, which is how our oceanographers measure phytoplankton biomass. And basically, blue is low and red is high. So looking on the left-hand side, at temperature, you can see that it's we have warm waters, relatively speaking, down in California, and then getting colder and colder as we move up into Alaska. And what's quite interesting, you'll notice, is that there's this strong transition here as you're approaching British Columbia. And approaching because the circulation is starting back at all the way west of Japan, and the water is flowing across the Pacific. And then at this, at basically the top of Vancouver Island, it splits into the Alaskan current and the California current. And so the California current's at warm water and the Alaskan current cold water. So we have this quite dynamic region, and that can move around depending on what's happening with climate. And that means that you have quite a dynamic area here in British Columbia. There's also a current that goes up the coast inside the California and Alaska currents that can transport, it goes from south to north, and that can transport animals up from California. And that is also driven by climate. And when we have El Nino, that's when we get a lot of transport from the south up in that current. We end up with a lot of sort of new species coming into the coast. And just to highlight here, all the red on the right-hand side are this phytoplankton biomass, and you can see here West Coast Vancouver Island and Australia, Georgia. It's a very red coloration. It's telling you it's super productive. So we have really productive coastal waters in British Columbia, and hence the fisheries. And for more important context here, so like this is a long way offshore. Right? So why do we care about that? Well, I mean, physically, it's you know what this water is moving towards British Columbia, so it affects coastal ocean just physically and chemically. But our favorite animals in British Columbia, our famous marine species, salmon, for many anyway, they migrate. So this is Vancouver Island, a bit of a different sort of orientation in this map, but there's Vancouver Island, the Fraser River. This is Aleutian Islands over here. So the fish, the salmon are migrating out to the north, and then they move anti-clockwise and come all the way back to British Columbia. So they use this area. So we do actually really have to pay attention to what's going offshore, because that's very important for our precious salmon and their health and survival getting back to spawn in British Columbia. All right, so we have the big picture ocean context. The other thing that's unique about, well, very important, it's not totally unique, but it's like something that's very important in British Columbia, is that we're in the North Pacific coastal temperate rainforest. There are other coastal temperate rainforests in the world, such as in Patagonia, but this is the biggest continuous tract of rainforest on the planet. And so that contributes to this amazing coastline. It's very incised because of all the rainfall. Huge amount of fresh water is transported off the land. And so I'll just highlight here on the left-hand side, this green coloration is the extent of this temperate coastal rainforest, which basically goes from California all the way up into Alaska. And so British Columbia, again, is smack bang in the middle of that. And what this means is that we have this huge amount of fresh water that's constantly running off the land and into the ocean. And so there's a huge amount of transport of freshwater and nutrients, different types of inorganic and organic nutrients into the coastal ocean. And that gives British Columbia coastal ocean very unique properties. It's a very important part of the system. So when you think about the ocean, you cannot forget about the land. You have to pay attention to what's going on there. So, and some of the important components of the land are glaciers, and we have a range of watershed types. So we have low elevation rain-dominated systems to these high elevation glacier-dominated systems. And as many of you know, the glaciers are declining, and that's affecting the flow of materials into the ocean, the type and the timing of material flows. And that's very important for the processes that are happening in the coastal ocean, including like plankton productivity, which is the thing that really supports the food web. Some of that material is even transported way out into the Gulf of Alaska by eddies that form on the coast. And one of those formation points is at the bottom of Haida Gwaii. So we have something called Haida eddies that can be 500 kilometers in diameter, that can transport fresh water and essential nutrients thousands of kilometers offshore, supporting the salmon food webs that are so important. Okay, so that's just some brief context for British Columbia ocean. So let's get onto climate. So how's climate changing the fundamental properties of BC oceans? So this is a figure that many of you will be probably familiar with. It's showing change in global temperature and atmospheric carbon dioxide from around 1880 until present. The temperature is indicated by the bars, so the blue and red bars. And so if you just look at that, you can see that there's been this, this figure is actually in Fahrenheit, but the change that you're seeing from 1880 to present day is about 1.5 degree increase in temperature. And this gray line is tracing carbon dioxide. And that is, so it's increasing, and the increase is steeper through the 20th century, and that's the greenhouse gas that's causing the atmospheric warming. Okay, so this is in the atmosphere, and we're talking about climate, and so there's atmospheric climates, and this atmospheric conditions is transferred to the ocean climate, so the ocean conditions. So the heat is transferred into the ocean, and then the CO2 in the atmosphere dissolves into the ocean, and that causes something that you'll have heard of as ocean acidification. Okay, so those are two very important sort of results of anthropogenic CO2 production: ocean acidification and ocean warming. So, and this figure here is showing you ocean warming, and you can see it tracks the atmospheric increase in temperature really well, again going from 1880 to around to present day, well 2021 anyway. And yeah, it's about a 1 degree increase in ocean temperature. And that's the global average. If you look at a map, this is the sea surface temperature trend in degrees per century. Again, red is showing increase, blue is showing decrease. And what's interesting here is you see a couple of areas of the global ocean where temperature is actually decreasing. So, you know, it's not just one thing. The ocean is a very dynamic place, and there's some particular circulation processes that can often related to sea ice. So you'll notice that the places where it's cooling are in areas where you have, they're towards the polar regions where there's actually ice influence, where there are some currently declining temperatures, but the global ocean, the global average is increasing, and you can see in our area of interest, Northeast Pacific, temperatures in British Columbia are certainly increasing. And so I'm just going to go back to this plot. So you can see there's like a steady increase. There's a bit of variability going on, and that's related to dynamics in the climate. And one of the things that is happening more and more is we're getting an increase in extreme events. Okay, so this is what we now are calling marine heat waves. This is a sort of dramatic illustration of the first big heat wave that we really recognized and people paid attention to in 2014, 2015. Became nicknamed the blob. There's a cartoon of the blob over here. The blob, the giant blob, is holding El Nino's hand just to indicate how dramatic the impact of the blob was on ocean conditions. So this happened in 2014, 2015, and then since then we've had recurring heat waves, and just it's become an area of intense interest. There's a lot of researchers focusing on marine heat waves, trying to understand them and keeping track of them. There's this webpage, marineheatwaves.org, where they, you get constant updates of how ocean conditions are developing. And this is from October 2022. And the map is not very clear, probably at the back there, it's quite faint. But this is, British Columbia is here. And you can see we're actually in what is rated as severe conditions. So there is a heat wave currently developing off our coast, which may impact again conditions in next spring and summer in BC. Right. So atmosphere-ocean connections are real, and these are events that you would all have experienced. Then we get heat waves in the ocean, and that's reflecting atmospheric conditions. Dry summer in 2022, we had a lot of fire. We've seen a lot increase in occurrence of fire over the last decade. And then this is the atmospheric river that happened in October last year that caused extreme flooding in the Fraser River, in the Fraser River Valley. So I'm putting these up here because this is really important for the ocean. And this is one of the aspects of climate change that people perhaps not linking to the ocean. But looking at the fire, you have all this smoke. The smoke goes out over the ocean, and then there's a lot of different types of materials, carbon, metals like iron, which is actually quite important for fertilizing phytoplankton blooms, various materials that are transported into the ocean, and we don't actually know in this area how they impact productivity, the food webs, and the ecosystem health. So this is an area of research that is always waiting to be stepped into, because this is a growing problem and we need to understand it more. It's not only about smoke though, it's also about how fire affects the land. And we know from other parts of the world that when you have burning and then you rain, you get like an extreme contribution of nutrients into freshwater, into the rivers, and that's going to be transported out into the ocean. And there's a lot of nitrates and there's a lot of phosphates. And phosphate in particular is very, it's something that cyanobacteria really love and need. And cyanobacteria are the #1 cause of harmful algal blooms. So it is something to pay attention to, that by changing nutrient chemistry because of fires and the freshwater runoff can actually impact harmful algal blooms in coastal waters. This flooding here is really interesting or important because it happened at an unusual time of year, right? This normally, like the Fraser River floods in the summer, that's when we have the freshet, the snowpack's melting, the ice is melting. So this was almost like a freshet, but it was in the fall. So we have this massive contribution of fresh water and a lot of organic matter being transported out into the coastal ocean at a very unusual time. How that impacts the coastal ocean, we don't quite know. We can hypothesize, but we weren't actually out there measuring it at the time. But this is something to pay attention to, and it's likely to really impact coastal ocean processes and impact food webs into British Columbia. Okay, so how is climate change impacting BC's ocean ecosystems? Well, I've gone a little bit into that already, but I've got some other things to comment on. One is like a physical process of sea level rise, and that's something that I think folk in BC and particularly Vancouver really pay attention to. This is a forecast for sensitivity to global sea level rise, and the reddish color is high, orange is moderate, and blue is low. And what this shows you is that it's just very dynamic. And there's actually quite a lot of uncertainty about this, but the expectation is it's generally higher in southern British Columbia. And part of the uncertainty is about predictions of how sea level will change in the future, but also the isostatic rebound that's happening in British Columbia following the melting of the ice cap from the last ice age. The geomorphology is actually rising in some areas and sinking in others. So it's very difficult to predict. But severity relates to things like flooding, erosion, those sorts of processes that will be a factor in the future. Ocean acidification. So I'm just putting up some images here. These are indigenous animals that we have in British Columbia. This is a pteropod. It's a sentinel of ocean acidification and very important in the food web. Salmon love to eat it. And so we're paying attention to that and how it's being impacted. Of course, oysters. So these are animals that produce carbonate exoskeletons. So like or shells. These are the ones that are directly impacted by ocean acidification. And so obviously this is also a factor for the shellfish industry. This is Bain Sound near Denman Island, and they have had issues with ocean acidification already, losing a lot of the larval stages, which look like this. Okay, but so ocean acidification, or CO2 being put into the water or being taken up by the ocean, also impacts fish directly, affects their physiology. as does temperature. So warming oceans are an important factor for the indigenous species that are adapted to cooler waters. It can also bring in unusual species from the south, and this is what we've seen during the marine heat wave. This is a sunfish. These are sea, I think they call them, this is a pyrostome. I was trying to think of the common name, I can't remember it right now. Anyway, it's a pyrostome, which is a gelatinous tunicate that was very abundant on the coast, and then some harmful algal species. So those are like direct impacts on species, and all these species are linked together in food webs. And this is an example of a food web that's really focused around herring. Okay, so I was saying that, you know, salmon is everyone's favorite fish, but actually herring is the most important fish probably in British Columbia. So this is the herring life cycle. It's an adult herring. It's cured as spawning in the nearshore environment. The larvae and juveniles are on the coast, and then they sort of go offshore, feed on plankton, and come back again. This is such an important fish. It's a keystone species. It feeds terrestrial animals, so that land-sea connection. It feeds, so here we have shorebirds, bears, some nearshore invertebrates. I've seen wolves down on the beaches eating the herring roe. And then off, like in the waters, you have seabirds, whales, pinnipeds, and other fish, including salmon, that are all feeding on herring. Right at the center of that is where the business happens. So that's the plankton. So the plankton are really the engine of the food web, and they take the nutrients that are in the water and they convert that into biomass that zooplankton eats, and then that feeds the herring, the zooplankton, and everything else. So the herring and the salmon. And so climate change is impacting these lower trophic levels by changing nutrients. That change in nutrients can happen because of warming and physical processes in the ocean. It can happen because of the changes in runoff and contribution of different types of nutrients. So what that means is that the biomass is changing. We expect lower biomass with warming in coastal waters. It changes the species composition. It changes the fatty acid, the essential fatty acid contribution, and the nutritional health of food webs. You have less production of those omega-3 fatty acids that everyone knows about. That's very important for all life. So you have decreased production of those, and so it affects the nutritional health of animals and their ability to survive just in general, and also like tough conditions. And this figure here just shows that this is a Chinook salmon, and this is showing you diets. This is off the coast of California, the diets in the 1980s versus present day. This is all anchovy. So there's a change in the food web going on. So like this is something that we're seeing around Vancouver as well, really a real increase in anchovy. What they found is that eating too much anchovy is really bad for you because it causes vitamin B1 deficiency, and so thiamine deficiency, and that is causing mortality, like excessive mortality of juvenile Chinook salmon. So this is a problem that hasn't actually been assessed in British Columbia yet. It is a problem in Alaska, but it is something we definitely have our eye on and urgently need to start making measurements of in BC. So that's a nutrition issue. Okay, so what actions can we take to support resilient BC ocean ecosystems? And I see I'm about to hit 20 minutes here, so I'm going to do this very quickly and you can ask questions later. All right, so there's this climate stuff going on at a really large scale that's absolutely impacting our oceans. But we do a lot of things locally that are very bad for the oceans too. And urbanization has and does continue to have a major impact on the coastal ocean and organisms that live there through everything that we generate in those locations and put in the ocean. And I can elaborate on that. Fishing has a lot to answer for. The history of fishing, one of the major things it's done, well, it did reduce biomass, but it also, most importantly, or very importantly, it reduced genetic diversity within so many fish stocks. And herring being harvested, herring was one of the key ones. They were really fishing extremely hard. And so it's happened with salmon as well. So genetic diversity was decreased. And this means that there's less variability of life history types for any species to respond to a changing climate. So we really need to bank as much diversity as we can so that animals have the greatest chance of surviving climate change and impacts it has on the ocean. This is a picture of the herring spawn off Denman Island in the Salish Sea, just to show you that there still is like significant herring biomass. There still are things to hope for. And one of the, so like we can take actions at the local level and how we implement our fisheries, how we impact the coastal environment through urbanization and industrialization. And one of the key things we need to do is start also incorporating traditional ecological knowledge, First Nations input into how we sort of understand our system. So, different ways of knowing, not just employing Western science in our research and management and policy implementation. So those are some important steps forward. Thank you.
Go. I mean, pressing a lifetime of study and into 20 minutes, not that easy, but thank you. I learned a lot, and I know that our guest did as well. So now it's over to you for questions. So yeah, Brian, these will be questions directed towards you. So it's a Q&A period for 10 minutes.
Yeah.
Right. I'm very interested in your statement that reducing genetic diversity was a major approach. Is there any quantitative measurement of where the diversity is now compared to what it used to be? Is that what
Not in British Columbia, but there have been this. It's well understood. I mean, it's understood for some systems, and it's been well demonstrated that genetic diversity has this effect. So, like Bristol Bay is the first big example that was put forward by scientists. So there's a lot of different salmon stocks, and they have varying levels of success from one year to the next, but the total biomass of fish returning every year stays pretty much the same. But stocks are going up and down all the time, and this is really because of the genetic diversity and how they're able to deal with ocean conditions. But this is not something that's really been measured, not at the genetic level in British Columbia, but one way you can assess it, and this has been done. This like the herring is a really good example. So historically, herring used to have like a very diverse array of spawn timings. They used to spawn from around February all the way through into the late summer, even into the fall in some places. Now, pretty much, I think all herring are spawning in the spring. There's a couple of small populations like Cherry Point that spawn a little bit later. So like there's been this compression, that's a reflection of genetic diversity. So there's been this compression of the fish into the spring to spawn timing. So like all the eggs are in that basket, literally. And so that's really dangerous because the springtime is something, there's the timing of like phytoplankton production and zooplankton production, and it varies from year to year, and that's something that's being impacted by climate change. And this herring spawning is supposed to be timed to match that, to give the best conditions for the larvae and the juveniles. And so it's really risky to have everything so like the spawn timing so compressed around that period. That's actually quite dynamic because of climate change.
We have another question over here.
For those of us that have paid attention to First Nations concerns for years, herring has been at the top. It's been before y'all at the universities, got it published. I know you were interested. However, my concern is seeing that we've already had a decrease in so many species. And I'm wondering all the way up to Alaska, is it the king crab or the snow crab that have decreased? And I'm wondering about that, along with everything that we've had down here on the coast that are decreasing in numbers.
Yeah, it's the king crab, and I'm not sure that, this has only just been happening. I'm not sure that it's really understood what's caused that. So all these animals that we talk about, they have complicated life histories, and so the primary driver of change could happen at different points. And like the king crab has a larval stage where it's in the plankton, so it could be conditions change there, but there also benthic, and it could be conditions like as adults, and conditions change there as well. So in the deep ocean in British Columbia, one of the important factors which I didn't mention is deoxygenation. So it's impacted by circulation change, warming as well. And so there's a long-term sort of decrease in oxygen in the coastal waters in British Columbia, and also offshore waters too. So that could be a factor. Yeah.
Hi, Brian. My name is Wendy. Nice presentation. I noticed there's a spike around the 1940s in ocean temperature. Was that due to the war years?
I'm not sure if it was due to the war. Maybe someone here, maybe someone does know. It could have just been a climate anomaly. I mean, we do have climate oscillations that impact temperature. Yeah.
Well, I didn't realize the impact that smoke had on the oceans until you told us just now. I'm wondering about the state of the world and the wars that are going on, the missiles coming from North Korea. What impact is that having on our oceans?
Right now, no impact from North Korea here, thankfully. I think that the examples where it's like the smoke effect or like the fire effect has been very evident, have been like very big fires, and I think that we'll see that here in British Columbia. But a good example is in Australia. They had huge fires. I think it was 2018 or 2019, and there was a smoke plume that went all the way across the Tasman Sea to New Zealand. And so like there were multiple effects. One of them is that it decreases light penetration into the ocean. That probably is a factor here, and that means you have less photosynthesis. But then you also get iron inputs, and that can stimulate production. But then you also get smoke. So what happened in New Zealand was smoke was settling on the glaciers and increasing ice melt because of the albedo effect. So that is something that would be a factor here. So it can speed up deglaciation as well, which is also connected to the ocean because it changes the freshwater flow of the ocean and material transport.
One more question back there, and then we'll have to move on. But
Make sure that if any of our Zoom participants have questions, that will be affected as well.
so this will be your last time to ask questions to Dr. Hunt. So I believe.
Thank you very much, Dr. Hunt. My name's Chris. I have family in the Port Alberni area. My question is really comes from there, and it's a focus on overfishing. Now, it's interesting. The Port Alberni, in a sense, is a closed fishing community. They have a very large canal, the Alberni Canal, which extends well into the interior of the Vancouver Island. It has a fish hatchery at the top end. It has an indigenous fishing at the top end. There's a very large sports fishery, and there's a corporate fishery, all interacting in that area. Now, these groups do meet. They meet in the early part of the year. They decide how they're going to fish, but they're very often focused on a fantasy number because the estimates are just that. You don't really know how many fish are going to come in there until they actually arrive. These three groups are well aware of the degradation of the headwaters of the top end of the canal. They're well aware of climate changes. They're well aware of the changes in temperature in the canal. They're well aware of the impact of Alaska fishery on that part of the fishery down the coast, and they're also aware of the China problems of overfishing. And they've done their best to try and counteract that, but the fishery declines. The salmon stocks are declining, and all you have to do is ask the sports fishery, and they'll tell you. And so my question is, with all this information, why aren't there more closures? Because it seems to me that if you're going to save the stocks, you've got to stop taking them out of the ocean. Now, it's interesting. About 30 years ago, my brother thinks, maybe a little longer, they actually closed the salmon fishery, and they had enormous returns as a result of that. But of course, they were soon fished down again. So my question is, what about closures? I mean, as one of your action points, close the fisheries and allow them to recover.
It's a good suggestion. You should put it to fisheries and oceans.
Well, I'm compelled to reassure you, Chris, that there have been some very significant closures, and it is targeted at specific runs in trouble as opposed to blanket, because some runs are not in as much trouble. And secondly, part of the Pacific Salmon Strategy, which is a $650 million strategy to address and restore wild salmon, has a boat retirement program. So we will be launching purchasing back salmon fishing boats, so that those for whom it's their livelihood and their bank of funds that they've put their money into over the years, that will have an opportunity to sell those boats back to the government, and not because these closures are going to have a huge effect on their livelihoods. So we are working on it. Is it enough? I think that's always the question. So now we have Mr. Wong. So Andy, on a different kind of the bookend of the challenges and the impacts, we've got some ideas coming out of OceanWise as to one way to begin working on rebuilding ocean abundance and diversity. So over to you.
Awesome. Thank you, Ms. Stewart. Check. Oh, perfect. Great. So yeah, thanks, Dr. Hunt, for that presentation. That was really interesting and frames kind of what I'm hoping to talk about really well. That has really given us the reason why we're pursuing our Seaforestation initiative. So today I'm going to talk a little bit about what we're up to, kind of the reasons why behind why we're focusing on kelp of all things, and then hopefully some of the benefits that we hope to see from our initiative and see in the future. So just a little bit more about me. I grew up on the coast of BC, on the traditional ancestral and ceded lands of the Musqueam, Squamish, and Tsleil-Waututh First People. And I had the privilege to grow up around the ocean. I spent a lot of my time in my youth on the Sunshine Coast, snorkeling up in Malcolm Island, watching for whales. And so that combined with my kind of academic background in food systems really helped to create this passion for an ocean solution that works for people as well and the climate. So for those of you that don't know OceanWise, we are a globally focused conservation organization that is trying to turn knowledge into action for the oceans. So we have a number of initiatives that all try to address kind of the main challenges that are facing our oceans today, such as ocean pollution, overfishing, and climate change. And so within that, there's multiple conservation initiatives, including our whales initiative that focuses on whale health, our plastics initiative that looks at plastic reductions and microfibers in the water, our seafood initiative, which you might recognize from restaurants and grocery stores, where you can see our OceanWise label on sustainably sourced seafood, as well as our youth and education initiative, which engages youth kind of across the country and globally every year. So Seaforestation is the newer of those initiatives, and we focus on kelp forests. And so forgive me, I have a background in education as well, and so I usually include some true or false to kind of warm everyone up and assess what our knowledge of kelp is in the world. So our first question for true or false: kelp is a type of plant. Do we think that's true or false? You can maybe raise your thumbs up if you think that's true, or down if you think it's false. Is kelp a type of plant? So the answer is actually false. Kelp is an algae. It's in the kingdom. It's not in the kingdom of Plantae. It's in the kingdom of Versta, but it functions very similarly to plants in the ocean. So it photosynthesizes, which means it turns carbon dioxide and energy from the sun into oxygen and biomass. And kelp can grow at an incredible rate, which makes it quite a special organism. Certain species of kelp can grow almost a foot a day or 30 centimeters a day in prime conditions. Our second question: kelp forests cover 2 times more ocean by area than coral reefs. Is this true or false? These are some kind of tricky questions, I'll warn you. So this is actually false. Kelp forests cover, we think, almost 5 times the amount of ocean as coral reefs. So kelp forests are really important on coastlines in temperate regions of the ocean, all the way from, is this the clicker? Yeah, there we go. From British Columbia, all the way across to Atlantic Canada, to the UK, Japan, and then down south in South America, South Africa, and Australia as well. So they're an incredibly important coastal ecosystem all around the world. And our final question, kelp forests in certain bioregions are declining 4 times faster than tropical rainforests. Okay, what do you think? True or false? This is a little less of a trick question. This is true, unfortunately. So we're seeing massive declines in kelp forests across the world. At what is estimated at about 40 to 60% of global kelp has declined since pre-industrial times. So that's kind of the reason why we're focusing on deforestation, which is the act of planting, managing, and caring for underwater seaweed forests. And so our ultimate goal of this initiative is to restore and cultivate kelp at scale in ways that maximize climate, biodiversity, and livelihood benefits. So to kind of break this down a little bit more, we're hoping to restore and to grow kelp at a scale that matches the pace of decline and the kind of threats that are facing our ocean. But we also want to do this in a way that doesn't just focus on putting kelp back in the water. We want to focus on maximizing the benefits of this. So the benefits to people, to climate change, and to the oceans. So some of these benefits that we talk about to the oceans and climate are fairly self-explanatory. Kelp forests create very important coastal habitat for multiple species. So things like Pacific herring, abalone, sea otters, as well as juvenile salmon. So they are incredibly important to the health and functionality of the ecosystems that Dr. Hunt presented on. They also capture carbon. So this is one of kelp's kind of superpowers, is that it is a nature-based solution to climate change, and the fact that as it's growing, it's taking in carbon dioxide from the water, storing that in its tissue as it grows. And so a lot of this tissue is recirculated back into ecosystems. Some of it washes up on the beach, as I'm sure you've all seen on the beaches here. But a portion of that tissue is actually transported to the deep ocean and sequestered for large timescales between 100 and even to millions of years. We're trying to figure out exactly how much of that carbon goes into the ecosystem. It's actually quite hard to track kelp because it gets uprooted or upended and then transported like thousands of kilometers out into the ocean where some of it sinks. But there's estimates that it's responsible for sequestering millions of tons of carbon per year across the world. Additionally to that, kelp forests help buffer their kind of microclimates from the effects of ocean acidification as they are producing oxygen and kind of oxygenating the surrounding waters. And they can also remove excess nutrients from the water. They absorb nutrients incredibly quickly. And so they're used, they can be used to kind of battle eutrophication. One of the ways that they do contribute to ecosystems, which ties in really well to the previous presentation, is through herring. So herrings are a beautiful example of a keystone species that is reliant on kelp as kind of a main part of the life cycle. So these herring, as you saw that beautiful picture of the herring spawn, I've never seen one in person, and I would love to go see a herring spawn myself. But the herring tend to lay their eggs when they spawn on kelp or on eelgrass. And so they use that as a substrate to lay their eggs. It helps protect the eggs from floating away, from predation sometimes, and provides a stable substrate for those eggs to hatch, as well as really important habitat for the juvenile fish when they're growing up and they're very vulnerable. So because kelp forests are incredibly important, this herring roe on kelp is also a very important fishery for coastal First Nations. So it's really culturally important all throughout the coast, especially up north. And this is kind of some of the background of why we care about kelp forests from an ecosystem perspective. So moving past just the ocean and the climate, there's a lot of benefits to coastal communities and to livelihoods and people around deforestation. So focusing on restoring and cultivating kelp can bring food security benefits. So from the stabilization of ecosystems, from the creation of habitat, as well as from the actual harvesting of kelp, can it benefit food security. It can create positive livelihoods and potential job opportunities for both restoration and farming activities, which can bring kind of economic opportunities from in a decarbonizing world. And it's really important for creating low carbon products. So there's a lot of talk these days around the potential of seaweed and kelp in different sorts of products that are really essential for us humans and we use every day. So that can be from seaweed-based bioplastics, which can be fully biodegradable plastic alternatives. This can also come from cattle feed and agricultural feed. There's some studies happening right now that are looking into the methane reduction when you feed cattle seaweed and kelp. And it's looking fairly promising. We're still in the early stages of that research, but there is some companies that are starting to implement seaweed-based cattle feed to reduce methane. It has potentials for biofuels as well as just a general food source. So lots of different ways that seaweed can play into our lives and the lives of kind of our changing economy. So now we know kind of the why. This is what we're hoping to achieve. But the question is, how do we get there? How do we restore, cultivate, and maximize those benefits? So what we're doing at OceanWise is developing, testing, and adapting restoration techniques that can be taken to scale. So trying to find ways that we can restore kelp as well as address the initial causes of decline. There are a few different initial causes of decline. Climate change is one of them, and that's one that is quite worrying in the future. But there's also human kind of additional human causes of decline. So one example of this is the hunting of sea otters in the kind of 1800s led to a increase in explosion of urchins populations. And so that has had long-term effects on kelp forest abundances. This is kind of a very well-known example. But more modernly, we're looking at heat waves being one of the main causes of kelp forest decline, all the way from Southern California all the way up to BC. So by developing these restoration techniques we take to scale, we're kind of setting ourselves up for being able to restore these ecosystems, especially as we see climate change further causing those declines. As we design these restoration techniques, we're also hoping and working with coastal communities and First Nations to co-develop these restoration projects. So figuring out ways that, as I mentioned, we're not just planting kelp, we're also maximizing the benefits to people, to livelihoods, and to culture. We're then hoping to measure the environmental, social, and economic returns of these activities to kind of incentivize funding and ultimately make people care about what we're doing. And we're also hoping to collaborate with government to streamline the restoration through incentives and through regulation processes, because that's one of the larger barriers to restoration right now. So I'll give you a quick project update of our kind of pilot project that we did in Rainy Bay, which is an area, it's New Channel territory close to Banfield on the west coast of Vancouver Island. And this is where we were testing, green gravel as a restoration technique, which is the seeding of kelp onto gravel. So you take kind of regular sized gravel that we'd use for construction for your yard, and you basically inoculate it with juvenile kelp. So you take the reproductive sori from kelp in the wild, you release that into the water, and then you have it attached to the gravel there. And so this is what it looks like after a couple of weeks of growing. And the idea is it's a way of restoring kelp and seeding areas of kelp without having to add too much infrastructure to the water. You're just basically changing the substrate like lightly by sprinkling gravel over it. But what you're doing is introducing the kelp genetic material back into an area that's seen a decline in a kelp forest. So in December 2021, we worked with a couple divers to outplant and to choose a couple areas to test this green gravel. So these are two transects. They're 100 meters long each. And we decided to test those. There's different substrates at each transect. And try two different types of kelp. So there's Nereocystis, which is better known as bull kelp, which is the kelp that looks like a whip and it's got the bulb on it. And then there's Macrocystis, which is giant kelp. And so that's the kelp that's California is kind of famous for, but is also very popular here. So we outplanted about 200 meters of kelp on these two transects. And then we went back in April of 2022 to kind of visit and see how they were growing. And so usually in April, you start to see the juvenile kelp. Sorry, these slides are skipping a little bit, but you start to see the juvenile kelp pop up. You start to see the growth that you would expect. And in April, we went back to our transect sites and didn't see that much kelp, to be honest. We saw a few kind of smaller kelps popping up, see these juvenile pieces that are attached to gravel. So we were kind of had mixed results. We were looking, there was a lot of predation from animals like turban snails and urchins. So we were ready to kind of look into the next year's trials and figure out what variables to change. But we also went back in September of 2022, so September of this year. I wonder if I can play this from here. I just hit play. So we went back in September of 2022, and our divers went through the transects that we had chosen. And we were lucky enough on our macrocystis, on our giant kelp transect, to kind of see this growth, which was really exciting. So this was right along that transect line. It's quite hard to tell exactly if it was definitely our kelp that planted this, but given the area and the timing and the lack of kelp before, we were fairly confident this was from our seeding techniques. So yeah, these are fairly successful giant kelp plants. They're about 3 meters tall right now. And one of the most interesting parts of the observations that we saw was significant increases in biodiversity after just a few months of that kelp being in the ocean. So one of the divers we work with has been diving in that area for 20 years and said this is one of the most biodiverse spots that he's seen in that area. And so we're fairly excited that we're seeing that response already. So we're hoping to measure that more quantitatively. That was very qualitative observation, but this is a few hundred meters, so we have a lot of work to do, but this is kind of the baseline of where we're moving from. And so what's next? Basically, we're going to continue monitoring that site in Rainy Bay and see how it does in multi-year stages, because there's a chance that marine heat waves come through and they decimate that, but we want to understand if it can persist for multiple generations. We're opening a kelp nursery in the Pacific Science and Enterprise Center, which is in West Vancouver. So that'll be kind of our hub for restoration work and for research and development of that. And we're hoping to use that as also an educational hub as well. And really the next step is co-creating these restoration projects in the South Coast and all the way up to the coast of Prince Rupert. So working with First Nations locally and up north to kind of figure out what restoration looks like outside of just growing 100 meters of kelp. How can this be done in ways that, as we talk about, maximize those benefits to people as well and livelihoods. And the one thing I don't have on here is the creation of like a restoration roadmap. So that's one of our critical pieces, is understanding the layers that will happen. So for example, where waters will warm in the next few decades, and understanding if we do restore in certain areas, will they be wiped out by marine heat waves? How can we combat those causes of decline? And so ultimately creating a layered map that will let us kind of inform our restoration activities moving forward is going to be critical for that. But yeah, overall, I think we're hoping that the Seaforestation Initiative can do the things that we hope it can. So it's about implementing it in a way that it does maximize those benefits and making sure we're measuring that in the future. But I think that's everything I have to say. Yeah, thank you.
Well, thanks so much. And I think everybody could see that I learned something from this, because my thought was in the wrong direction 2 out of 3 times. So that was super interesting. And Andy, you don't get to sit down yet. There's a Q&A for you for the next 10 minutes or so. And Denise, if there's anyone on Zoom that has a question, let's go to the Zoom question first.
No questions from Zoom quite yet. So we'll start with, there's lots of.
And I'll note that there's a couple of chairs up front here. I think there's a few guests that have come and don't have a chair at the back, so you're good? Okay.
Yeah, thanks very much. Great presentation. We're doing some work with the Climate Champions in Hook Bay, which is pretty rich ecological waters. And one of our champions is an ecologist, and he's very worried about the impacts of runoff from non-point source pollution on things like eelgrass. So my question is, I don't know if you're looking at eelgrass, but do you get similar effects of urbanization that Brian mentioned on kelp? Is it these sort of, you know, the toxins, the fertilizers, the plastics, etc., that goes into our stormwater? Is that a concern for the kelp as well?
Yeah, no, that's a great question. So it is a concern in certain areas. So we've seen kelp forests decline areas like Burrard Inlet, there used to be historical kelp beds here that have seen almost been completely wiped out. It's hard to tell whether that's through things like sedimentation and kind of other development issues, but ultimately kelp is a bit more resilient in the way that it can absorb an incredible amount of nutrients and toxins. So there's a bit of research happening now of kelp as a way of buffering areas of ocean from these runoff events. Obviously, at a certain level, the kelp can survive that. But there's a bit of a way where, yes, it's a concern, but it also has the potential to buffer other areas of the ocean from those effects if it's planted in the right areas and it's resilient enough.
Thank you. A very interesting topic, I find. A couple of observations. One is that it looks like much of your effort is designed to get rid of negative effects on kelp, basically protective, I guess, if you will. Curious, how does kelp actually reproduce itself? Because your other emphasis seems to be on positive steps that can be taken, and I would imagine your goal is probably the restoration of millions of square kilometers of kelp when you're dealing at this point with maybe 100 yards. So, thank you.
Yes, so the life cycle of kelp is really interesting. I use like ferns as kind of a proxy of how to describe it. It's not super accurate, but basically they produce the spores. So on the fronds of kelp, they will produce spore patches. And then it releases like millions and millions of zoospores, which are actually kind of free floating and / swimming, some people say, spores that will attach themselves onto the bottom of the ocean. And then they actually reproduce a mate. So there's a male and a female, and they produce a sporophyte at the bottom. And then that grows into the adult. So it's an interesting life cycle. And the idea is that like bull kelp is one of the species that's common here. And where it produces spores is actually at the surface. And so warming oceans are impacting the spore production. So that's one of the main issues, is that the spores that are held in the fronds are being killed, or like they're not sexually viable. So that's causing like a decline because there's no second generation. So if there's ways of figuring out how to enhance bull kelp's resilience and resilience to produce spores, that's really important, as well as kind of subsidizing the population through restoration techniques, so making sure there's more spores in the water.
Thank you.
You mentioned that you're having some success with the giant kelp. What about the bull kelp that you planted? I noticed you didn't mention it.
No, that's very observant. So the bull kelp, we do not see any growth in. It was potentially due to the site we selected. So the site we selected is much more viable for giant kelp. Bull kelp really likes high currents and high nutrient availability, as well as like slightly colder waters. And this was a bit more of a protected area. So we are trialing up north in Prince Rupert area. We're trialing bull kelp cultivated on vines as a restoration method. It might be better for the green. The one flaw of green gravel is that when you put it in a high current area, obviously it moves a little bit. So we're looking at other solutions and other restoration methods that will work better for bull kelp, and kind of understanding why our first trial failed for that. So.
Just quickly, we did have one question from Zoom that asked, what is the future of agricultural kelp for food use?
Yeah. So that's a very heavily linked part of kind of our work. Is we're not working directly on kelp cultivation, but there is this kind of way that cultivation can be like beautifully linked to restoration, because kelp farming will be very important for food production, but also to create a lot of those products that can replace kind of carbon intensive products in the future. And so we're kind of talking to different kelp farmers about ways that they can either restore as well as cultivate, or create a blend of restoration and in ocean cultivation to bring those benefits while also creating kelp farming for food.
Hello, great presentation. That was really awesome. I'm a big kelp enthusiast as well. I love canopy kelp, the bull kelp and the giant kelp. And I've been up and down Burrard Inlet and Howe Sound and hadn't seen any at all. And you were saying it is indigenous to those bodies of water. How do you know this? Like, I know there's some historical mapping going on at UBC from old Admiralty charts. Is that how you've seen like that there's bulk kelp in these areas, or?
Yeah, so there's the inlet has had bulk kelp historically. You can see that through kind of the Admiral charts that Mr. Costa's lab is putting together. We see it through some of our old mapping, but also through traditional knowledge. So talking to the nations that have been in the area, like Tsleil-Waututh, there's very strong like consensus and knowledge that there were bulk kelp beds in the inlet. There's a couple that are still existing up in the Arm, so there's kind of residual kelp forest there, but they seem to be. I think there's some folks doing some research on exactly why those ones have survived versus why the other ones have been wiped out. And then there's that bed by Stanley Park. So there's kind of these residual effects, but you can see that there's, the declines have been kind of passed along.
Oh, sorry, one more thing. I was at New Brighton in the spring this year and saw little baby bulk kelp growing there, which was like mind blowing.
That's awesome, because New Brighton just underwent, I think, a shoreline restoration project. And there's eelgrass there, but it's awesome to hear there's some bulk kelp kind of popping up back there.
I have one last question, or I think we already.
Thank you. I'm wondering if you monitored the populations of sea urchins before and after on the restoration sites.
So for this, the trial that we did, there were very little urchins in that area, which is nice. That was kind of one of the site selection variables because we wanted to remove that predation issue. We saw a couple of smaller ones. But as we go forward, urchins are a huge issue for kelp populations. And so we're implementing a monitoring protocol that monitors urchin abundance throughout the growing cycle and looks at how growing kelp might attract the urchins, whether that's going to be an issue moving forward in certain areas. So the answer is no, we didn't at our first site, but we will definitely be measuring it at our new sites.
There's more questions, and I have questions too. These are both such fascinating sets of science and initiatives to, I guess, address some of the concerns that we're aware of. So thank you very much for your Q&A. And we'll have, the good news is that there will be time for question and answer after all three speakers have spoken. And so file that question that you didn't get asked. And Charlene, over to you. Thank you very much for your part in this. I'm very interested in that as well.
Hi, Justin. Just going to start off. It was very thrilling to hear the presentations on the scientific side. Just going to move this so I can see you guys a little bit. I'm going to come at you from an Indigenous knowledge perspective. And our relationship to the ocean and the inlet is quite different from the scientific angle. Although it does affirm and brings true all the value and focus that we do have on the saltwater and the freshwater. We have a creation story at Tsleil-Waututh that our first grandmother was born from the sediment from the deepest fjord in Indian Arm, where our first grandfather was placed on the land, and he was frustrated because he saw all his relatives, the four-leggeds, the fin ones, the feathered ones, all follow around, and then they had little ones following behind them. And he was concerned that there was no little two-leggeds following behind him. So he went up atop a cliff and had asked the creator of all beings why this was so. And he got this message, and through that prayer, he dove into the water and went down to the deepest part and grabbed 2 handfuls of sediment and brought it back onto the beach and laid it on some cedar boughs. And in the first light, he laid down with them, and in the first light,
where he had placed the sediment was our first grandmother. And the message that he got was, you too will flourish. And when you look after one another, you look after the land, you give what the land, what you take. So it's all that goodness, all that prayer, all the no domination over one or the other. And you find your place in that circle, you will flourish. And so to this day, we have songs that pay homage to the wolf mother that raised our grandfather. We have songs that pay homage to our first grandmother that was born out of the womb of the earth, and such. So those aren't myths. Those are stories that I will tell my grandson one day, or my granddaughter one day. And as an elected person with the nation, with those values are how we make decisions within our organization. So I just wanted to share that little bit. I'm here on behalf of our climate action group. I do work with our nation in the Lands and Resources Department, but these are not my expertise. This is the work of a team of a department that couldn't be here today. And I'm going to share with you some of the projects that they've been working on. In the Climate Action Department and the Lands and Resources Department, they both had these projects. We started this quite a few years ago up in the Indian Arm. We've had a total of 45 creosote piles removed from the inlet, and as well as there was some industry up at the top of Indian River watershed, where we're still remediating some of the land up there and trying to remove it. We know that we can't bring it back to its pristine natural state, but with projects like these, this is our direction that we're going. Also up Indian River, we've got right by Granite Falls Marine, we have some riparian restoration and working on the shoreline there. Also as well at Granite Falls, we have the barge there unloading materials for the project. We also had opportunity to involve our land-based school that we have at Tsleil-Waututh, and had the whole school come and participate in some of these. So it's really an opportunity to pass down this traditional knowledge and to be able to show the true meaning of land stewardship and have that knowledge of the land be passed down. I just wanted to add, with the creosote piling removal, we've had a variety of partners. Sea Change Society, the Vancouver Plow and Drive C-SPAN. We all know that the creosote is toxic to fish, and many pilings are not removed when industry moves on. We did have history that the herring did spawn in these areas. So we do have been able to cite some of the herring eggs up Indian Arm. So we're pretty happy that some of this work that we have started with the removal of the creosote and the riparian restoration is going to help the ecosystem and all the habitats that were there come back. And just like that, you start to clear some of the salmon bearing streams and start to tidy it up, they will come back. And we have experienced that as well. there's 2 streams that we partnered up with to clean the salmon bearing streams. We've only seen a low count of maybe 1,000 salmon try to come back to spawn, where after the work has done, we've seen over 600,000. So we're pretty happy with those. Yeah. We're pretty happy with those results. We've also done some debris removal up and down the inlet. And this one was down by our, it's down by the end of Indian Arm. We have done some eelgrass restoration. There was a good, to my knowledge, when I was younger and maybe a generation before me, it was full of bull kelp. And I remember being a little kid being scared to go into the water because of the eelgrass and the big bull kelp, because of that eerie feeling of stepping it and it swishing around your legs. But yeah, we've again involved our school and brought them and replanted a whole bunch of eelgrass up Indian Arm, and it's been successful and to date. This one I'm pretty happy of, just because where we're situated is on the north shore of the Burrard Inlet, and along the inlet is, as you know, the ports. We've got the coal port, the chemical plants, the refineries, Shell Gas, Chevron, Kinder Morgan, BC Hydro, power houses. And I say that where we are is, right on the inlet. It's not our backyard, it's our kitchen sink, because we were able to have over 90% of our diet be harvested from the inlet. And over the last 60 years, we have not been able to harvest any of the shellfish because of industry and the pollution, and plus the tanker traffic and that propulsion of the tugboats disturbing all the clam beds. Where it was a point where I remember stories of my grandmother, that was her business, that was our family economy of collecting, say, potato sacks full of clams and going as far down as Seattle and over to the island and trading clams. And you go into territories, and I remember them traveling up the interior and trading buffalo for the sacks of clams. So that was our economy, that was our family business. We haven't been able to do that for the last 60 years, right where we are, but we've been able to clear a clam garden bed enough where we've had 4 harvests. And I feel if you've ever been over to the North Shore and the Deep Cove side, and you see all the industry, the Chevron refinery, the Parkland refinery, the Chevron, the Trans Mountain Pipeline Expansion Project, which is like booming right in our face. You just feel like that there's no chance for the herring to survive or clam garden beds to survive. But with the work of our lands and resources field crews and with partnerships, we've been able to keep this clam garden bed clean enough where we're looking at another clam harvest. So I really find that in my heart, that's a victory when we're up against all this industry. But to be able to find a way to keep our traditional knowledge and our heritage to a point where we're teaching our young ones, and it's part of the school, land-based school. One of the projects is for them to come down and hear stories, much like I had said, of it being part of our economy, but as well how to dig sustainably so that you're not decimating a whole clam garden bed and making it a sustainable way of life. But as well that cultural value too of what it means to be Tsleil-Waututh and to be able to harvest your traditional food within your traditional territory is a huge factor. We have field crews that go out, monitor the water, they test the shellfish, the mussels and the clams, and they go out every day. We also have relocated Roosevelt elk into our territory. And I don't think that's on here, but it has everything to do with the ecosystem and all the habitats that we see around there. And it's just the land coming back to life is what we're witnessing. We've been able to have clam knowledge exchange with the students, but as well with other neighboring nations who come and tell and share their stories and their history about the clam garden beds, but as well about clam harvesting and being able to share that with our youth. Here's our knowledge holders, our youth and our elders digging clams together. I was able to participate in this day, and it was just a way of, there's generational knowledge that can be handed down, but this was a day where we could hand down generational joy of feeding one's nutritionally, feeding our spirits, and feeding into a culture that, as we're surrounded by industry and very urban population, we were able to hand these things down. We had the brand spawning channel restoration, which I'm going to read up here. Building on many years of successful collaboration with DFO and 5 previous restoration projects in the Indian watershed, we restored a section of salmon habitat called Brant Channel just this past August, and it already has chum in it and lots of photos on this one. Okay, here we are digging out the channel and uncovering the channel buried by a major landslide. And again, you know, we're not everyone is affected by the climate change that is happening, and the effects that we've seen up in the Indian watershed has affected us too, with all the slide of all the dead trees and everything. And that's the before and after of the restoration. And we're already seeing the salmon come back. So it's like you build it and they will come. They know where to go. You know, this has been their tradition and their culture as well. So this is happy to see that they're already coming back and they're already spawning. So another success story for us. And that's it, starting to, all this black matter, I was able to go up, all the staff and leadership and everybody in the department were invited to go up and take a look at some of these projects. And I kind of had my pants rolled up and I stepped into the water and I was like, I can't see them, guys. And somebody said, throw rocks. So I threw a rock right where this black part is. That's all salmon. Yeah. And I was like, oh my gosh. And then pretty soon I started to move around and slap my foot a little bit. So they're starting to come back. And that too is you know, the rivers and the creeks ran so low. We're seeing that climate change happen where there's just no water for them to come back. And, you know, the work that we're trying to do and trying to help them with that dredging and make space for them to come back is a huge thing. Here's the killer whales coming back. We haven't seen these in the Indian Arm in probably 100 years. They used to come and fish. We also have a story in our family where one of my grandfathers was able to communicate with them. And he would go to the water's edge and just tap it, and they would come. And, you know, they had that communication. And it said that when he had passed, that's when the first settlers came. And how we took care of our loved ones is we wrapped them in cedar bark blankets and put them on this island. And nature took its course in that way. But we were told that's not the humane way to look after our loved ones. So we were told to put them in a cemetery. So we put our loved one in a canoe. And as we were bringing them over to a cemetery, which is now on our reserve, the blackfish, 2 of them stayed right beside the canoe and followed the canoe right to shore. And when it got to the shore and then the body was taken off, they backed up out of the inlet all the way past Second Narrows Bridge, Lionsgate Bridge. They backed out. They didn't turn around and they didn't go under, just out of respect. It was like a full-on funeral procession. And that was the last time that they were seen until 2015, 2016 is when they came back. And that is all the projects that we have on the go right now. There are many others, but these are the ones pertinent to what we're hearing about today. So, hi, Sepkasia.
Well, thank you so much, Charlene, and that sent chills up my spine, just thinking about the work that you and your community are doing and the impact that is having on the ecosystem and also more broadly on the population in Canada. So thank you. And now, are you up for taking some questions? Okay, so what I'm going to suggest is that all 3 of our speakers come up to the front. We have about 20 minutes for questions, and maybe the first questions would be the ones for Charlene, and then any other questions that you may have with the time that we have available. So does that work for you, Andy and Brian? Great. Okay, so Denez will be bringing around microphone.
Hi, thanks. You all learned so much. A question, is there a central website that we can subscribe to that would notify us when there are river and ocean cleanup times happening as a community?
Yes, there is. We do have websites, the Tsleil-Waututh Nation website, and then you'd have to look under the Treaty Lands and Resources Department section, but also the Tsleil-Waututh Nation has a Sacred Trust Initiative, which is paying obligations. Our very first obligation is to the land, and all the projects and everything that come into our territory have to go through our stewardship policy. So if there's any initiatives that are in there regarding ocean cleanup or beach cleanups, we've held before, is under those 2.
Okay, that was a lot of information. Could you just
I can maybe
print down?
Yeah, I can do something with these. Yeah.
Okay. And second quick question, probably for you, Andy, because of the ocean wise whale. When I shop for say canned tuna or salmon, I notice that there's a lot of other labels out there that aren't ocean wise that are encouraging people to buy it, but I don't think they're legitimate. Do you know about that?
So this isn't my area of expertise too much, the fisheries and seafood side. I know a bit more about how we like certify our seafood, and so we use like a 4 kind of section analysis that looks at like the stock, the fishery style, like with bycatch, as well as like feature projections. But I don't know too much. I can't speak too much to the other labels and how legitimate they are. Yeah. There is CEO.
Shall I say something about fisheries? There are 2 or 3 labels on the market in Canada. Oceanwise is obviously your first choice. You can't find Oceanwise. There's an international label called Marine Stewardship Council. MSC, they have a bluefish. They're equally good. And there's a label which is sort of going away, but you can still find it from the Monterey Aquarium. So these 3 I would recommend. And obviously, MSC, Marine Stewardship Council. That's 3 good ones. So obviously, Oceanwise is the best.
Charlene, thank you. Thank you for the slides. They were breathtaking. Many of the organizations I support are along the Fraser River, and what they're doing is they're returning wetlands. And so I know you're doing it, but do you have organizations support you? I know you mentioned some firms, but I would be very interested if you also have organizations where we can help fund with our donations, but we also can get out there and do all that work.
There is a way to help financially and like be partners or help through the TWN Sacred Trust. And again, I'll leave that information here. Thank you.
This question is directed at Dr. Hunt. I thought your response to the last question that you answered was unfair and glib when you suggested that people should contact Fisheries and Oceans to complain or advise them to close fisheries. And I think it's particularly true in the context of the example, the Barkley Sound fishery, in which this year I think 335,000 sockeye were expected to return. In fact, something in excess of 800,000 return. And I think it's a poster child of the minister's oversight of a department that's doing yeoman's work and is really world class in terms of its fisheries management. And Barkley Sound in particular is a model because it involves collaborative management regime in which First Nations, recreational, commercial, and Fisheries and Oceans Canada are at the table. And I think it's really gone beyond a sustainable regime, and it's become a regenerative fishery system. And all of this is so important because, as the minister pointed out, 70% of the planet is covered with oceans. 40% of the population rely on fisheries, and we absolutely have to get it right in order to ensure the productive capacity of the oceans. So, you know, I thought that you were just a bit hasty in terms of your response to something that I don't think was a fair characterization.
Can I respond to that? So I go to the State of the Pacific Ocean meeting, which is held by Fisheries and Oceans every spring. And if anyone wants to learn about the amazing work that Fisheries and Oceans done in terms of monitoring the ocean in Canada or British Columbia, I recommend going to that. It's open access. You can go there and you can learn all about the time series that are collected. And there are reports on salmon stocks, certain salmon stocks that are sentinels, and one of them is for Albany Inlet, and those sockeye have been doing very well. They're an exception. As you would probably know, like Fraser River sockeye salmon are not doing well at all, right? They're in long-term decline. Yeah, there's certain populations that do well. It is absolutely true that they are declining in general, okay? And not just there, but in other systems as well. So I think the main point, though, like the important point, is that it is variable, and there's some stocks that are doing well, and there's some that are not, and that's like those are things that we can look at, and we should be looking at to try and understand what's going on. And you might find that there are some things that are out of our control, like climate change, Barkley Sound fish or Albany Inlet fish are going onto the west coast and open ocean, whereas Fraser River fish are coming into the Salish Sea. And those two areas are responding very differently to climate change, and they have different human stresses as well. So yeah, it's definitely a complex issue. But that is, as you point out, it is a good example of a stock that's improving. How much that's to do with like human endeavor, it's probably fairly hard to establish. That could be more to do with ocean conditions.
Well, I might just chime in here and thank you for the shout out to the Department of Fisheries and Oceans and the, well, many dedicated public servants and scientists at DFO. I would say that challenge of finding a way forward that respects the importance of the oceans and the fish in the oceans to communities for food, but also for the economies of places like Atlantic Canada. So balancing that with managing in a way that is sustainable and indeed is restorative of ocean biomass is the key challenge, a fantastic intellectual and practical challenge that I am so excited to be part of as a minister. The science, fishery science, I mean, it's the classic cliche, it's not rocket science, it's far more complex. And I think you could see a little bit of that from the presentations, just the range of variables. So DFO works to get it right, but sometimes we got it wrong. And I think that there are things like the cod collapse on the East Coast. One of the things that I read about that is that there was a very robust system of assessing the number of cod and the changes in abundance, but what was not recognized at the time is you can't just count the fish and know that you are being that you're managing to sustain the stock if you're ignoring the fact that the value of a fertile, elderly, fat female fish, because that's who is actually regenerating the stock. If you're counting that the same as if it's a younger juvenile male fish, and you're giving them the same weight in your count, you're missing a huge factor. And I think we just didn't know that back in the 25 years ago or 30 years ago in the fishery science. So it's always moving forward and always getting more information from scientists that are working on these matters. And I think I see my role is to really make sure that the sustainability side, the climate side is fully part of DFO's mandate and actions, because it has historically been more of a focus on how you extract fish biomass from the oceans for social and economic purposes in a way that doesn't degrade the ecosystem. Now we have to be thinking differently, just for all the reasons that we're hearing, the unknowns around climate and so on, and being more precautionary and more focused on restoration is certainly the direction that I'm steering the work that I do at DFO. So, we're gonna take it to the next questioner.
Yes, I had my hand up a while ago.
I think we'll just, yeah. We need to give everyone a chance.
Oh, well, there were two there and some people too.
I have a question for Dr. Hunt. There was an earthquake in Japan quite a few years back. And then unfortunately, some of the radioactive waste was released or leaked at the time. And they're still releasing some of the wastewater right now. I know the ocean drift over this way. Is there any study or on the impact or?
It was monitored by Fisheries and Oceans and others. From what I saw, like there was monitoring of different types of organisms, animals. Salmon was part of that monitoring. So salmon were collected, we contributed to that as well, so collections of salmon from all across BC, just to see if there was like radioactive levels were increasing, or whether they were at dangerous levels. And as everything I saw was that they were not. So that was, yeah, it wasn't a big factor. It was a concern, but it wasn't. It ended up being unfounded. But one of the things that did happen was with the tsunami and sort of a suspension of a lot of plastics from Japan. And I mean, you would have seen vehicles and containers and all kinds of things washing up on the coast of BC. So one of the interesting things was that it takes a couple of years to get across, that they transported animals, which are invasive species, on the coast, or potentially invasive species. And it's quite interesting because that hasn't happened a lot historically, like pre-industrialization, because like the debris that would come across the ocean was wood, and the wood would generally get waterlogged and sink before it got to the BC coast. So the plastic enabled this transport across the ocean.
I might take, but so I know there's a couple of questions on this side, but I'm going to take a minute to just let you know the importance that I experience of my communications with people in Vancouver Quadra, with you, with those I knock on doors to talk to, or those that come in to meet me in my constituency office, where I'm not that often anymore, but I do continue to understand the importance of engaging with the community. And here's the example. Someone came to meet with me in my constituency office, and what they told me was that they had been picking up plastic from the remote islands off the coast, paid for by the Japanese government for the last 3 years, and doing it on a voluntary basis. But the Japanese government was paying for the fuel for their boat, the barging back of the plastic, and that funding had run out, and they couldn't find any federal funding. And so you may have heard the story before, but for those who haven't, I decided to tackle that as a project. So this is a number of years, this is like 2016, I think, and 2017 maybe. So I went to look into who's funding plastic in the oceans, and indeed, nobody federally. It was not DFO because they deal with fish. It was not environment because they deal with pollution on the land. It was not transport because they deal with things that are about ships, not about tsunamis in Japan. So nobody. And so I was able to make it into a campaign to where it became part of the G7 and the G7 environmental meeting, because Councilor McKenna took up the plastics torch as well, as did the Prime Minister. So that set of things is what it is an example of how the community matters, and how you speaking with your elected representatives can actually take something from a question or a request to action. And it is one of the big privileges of being your representative that I have access to being able to do that. So there you go. I just want you to know you matter, and the engagement that I do with the community is hugely meaningful to me, because it is about real things that matter to people. So there you go. Little spread.
Well, I have a very simple question. It's just about food. I used to love to dig for clams and make clam chowder, but I'm concerned about the clams that we're digging and the toxicity of the waters that are around those clams. And when Charlene was talking about those lovely clam beds that were regenerating, how do you know that the clams that you're digging out for our inlet aren't full of chemicals, toxins that may be coming from all the industry that's along that shore, the south shore, full of industry, and you're on the north shore? Do you test the clams for food health?
You have a good eye. Thank you for that question. Yes, we do monitor every day. We have a field crew that goes out, and I should have said that right off the top, that it's only a selected small section of a beach that is not in high traffic and it's not located or publicly located so that people think that clams are edible along Burrard Inlet, because it's not. They're not. It's just that one section. So we've had a couple of times where we've had people go and think that, oh, Tsleil-Waututh is clam harvesting, so it's okay for us to, and we've had to stop them and say, no, they're not edible. So yeah, thank you for bringing that up.
Environmental problems we hear about are overwhelming. And for many of us, it's hard to know where to start, and it's hard to keep despair at bay, But the one great idea I think about regenerating kelp is I don't know what the economics of that would be, but it sounds as though you'd get quite a lot of bang for the buck, and what's striking is the parallel between regrowing forests, on land, and now regrowing these forests in the sea, especially if in fact they do have an industrial potential. You mentioned plastics, for instance. I guess you'd need a hell of a lot of kelp to replace the oil industry's connection with plastic manufacturing, but that seems to me a really tremendous idea. And I just, in terms of a really huge campaign to do that, what kind of costing estimates might occur to you? How would you even assess that? And where would the money come from?
These are very good questions. So that's what we're trying to figure out ultimately is how we can lower the cost, because to date, kelp restoration is actually quite expensive, just because it's more of an academic exercise at this point, and the methods haven't been refined to a point that it's kind of like planting trees. But we're hoping kind of through iterating different methods of restoration and making sure we're keeping track of those costs to figure out where we can kind of intervene and what we can tweak to make it much more economically viable. And so the funding, that's also a great question. There's kind of right now a mixture of funding from private foundations. We kind of crowdsource funding, and we're looking for federal funding. And so the idea would be to generate enough awareness that we can find a mixture of all of those. And then kind of the flip side of that, where you mentioned plastics and the potential for industry. If that goes forward, there's potential for that to feed back into restoration work. So the idea would be to find ways where farming or restoration and the selling of those products can then lead to more restoration. So those are the ideas, broad scale, and so we'll see kind of what ends up sticking.
All right, we have time for one last question.
Okay, well, my name is Fernando. I work for the OECD and the Global Methane Hub, doing research on methane emissions from organic waste. And one of the interesting things about fisheries is that those are, 40% of our waste emissions actually come from water. Like when you put food down your garburator or any sort of organic waste that decomposes in shallow water on the sewage, it generates methane. And so there's a huge hole in data for how many emissions come from fisheries, because you have a constrained amount of fish producing a lot of organic matter and no ecosystem to be able to decompose it in a very oxygen with oxygen input, and so it generates huge amounts of methane, and we don't know what range. So what do you think is the regulatory capacity for us, knowing that methane in a 20-year period causes 80 times more warming than CO2? How could we regulate and measure the methane emissions from fisheries, and we know that from cows and I mean, that's why I'm a vegan, but that's another topic. But like, how much does it come, like, how could we measure it from fisheries versus what we know is almost no methane, like there's no methane emissions from eating fish normally, but like, how could we take a look at the methane emissions from fisheries? Because that's, no one has done it, and I think that's, I mean, there's a potential for a lot of emissions to come from there.
It sounds like you just need to do some accounting, and I'm not aware of any study that's particularly looked at fisheries' contribution to methane from the consumption. You're talking about the consumption side, right?
Well, I am like, no, like when you have like organic waste, like in on let's say a wetland, right? There's a lot of emissions there because there's a lot of organic waste decomposing in shallow water. And there's a documentary recently released called Leading Our Way to Extinction that explores what the bandwidth of emissions could be from there. And it's huge because we simply have never studied, given the fact that it is shallow water and there is very little biodiversity and like organisms decomposing through that organic matter. And so it sits at the bottom of the fishery and it releases a lot of methane. So my question is, how could we measure that, and if so regulated, because this should be a huge source of emissions that we could be ignoring because we don't have the chemical process and biological process does happen, right? Like we know it's being released, we don't know how much and how, and you know, like we don't have regulation of how deep, for example, a fishery should be to avoid, you know, it being shallow enough to generate more methane.
I guess it's not totally clear to me what you're referring to. So, I mean, is it like the fishing action on the environment in the like shallow waters, or is it the actual fishery itself?
Like a fishery, like an enclosed space where you have a lot of fish.
Oh, do you mean like aquaculture? Okay, right. Okay. Sure, that's a good question. I would think that there must be information on that, but I have not seen that. It would depend a lot on the environment where it's done. But yeah, like in shallow water where you don't have a lot of sort of transport, redistribution of waste, and yeah, you get those anoxic sediments and you can get methane production. But I have no idea what the figures are.
How could we, that would more go choice, how could we regulate that at the national level?
I think we're going to wind up because I like to end closely on time. And I know how a question easily turns into a conversation. It's natural. So we're at the end of our 2-hour town hall, and I just want to take a moment to first thank our speakers. Really the amazing Brian, Charlene, and Andrew for what you've contributed. Just having the perspective on what the Tsleil-Waututh are doing and just the leadership that you're showing. Thank you, Charlene, for sharing some of that with us. And Brian, the fact that you're taking your time as well this afternoon with so much, I mean, there is so much to do in the world that the universe that you're in to understand this, and without that, we don't have really a chance of being able to go forward in a way that is a good way, both environmentally, socially, and economically. So thank you for the work you do. And Andrew, you're like the front of the snowplow and figuring out how to do the restoration work. And Oceanwise is just, I think, an enormously important organization. And so thank you for your part in Oceanwise. Oceanwise has been on the leading edge of some of this, as I'm sure many of you know. In fact, when I was looking over this way at Michael, who you were doing work with Oceanwise when you were part of the consultations that I was hosting on oceans plastic and how I could get our government to take some measures on that. So thank you to Oceanwise, and if you're looking for
ways to support this kind of work. You can see that there's good work being done there that I am intending that we can leverage off with DFO. I mean, I can tell you from my very first briefing in Ottawa with the team of senior officials across the table from me, I was talking about kelp and eelgrass, and until they probably were rolling their eyes. But I can see now there is a ways to go before this is something that is being done extensively. But if it weren't for the work of the people on the panel, we wouldn't be where we are, which is, so let's just give a round of applause to her. So I also want to thank you for being here. I mean, this has really exceeded my expectations as how many people would come out. You have devoted a Saturday afternoon. That's precious. Time is something that's not renewable, really. So thank you for your interest and your questions and being here to learn more. And what I hope is that today has actually given you some optimism, that there are things cooking and percolating that are about restoration and about tackling some of the challenges that we, humanity, has really left for our next generation. So thank you. Thanks for coming, and thanks for being part of those who care about these issues, so that you did come here. And please pass on to your friends and neighbors the next time we have an event like this, and invite them to come as well. So thank you.